All right, so we know how significance test works. We did them last week. State plan do conclude. First thing we do in state is we define our proportions of interest. In this case, there are two of them. P1 equals some stuff in words. P2 equals some stuff in words. The two should sound very familiar except for one or two different words in them, because we're usually comparing groups that are similar except for one important characteristic that's different. We should label all the quantities we're given in the problem. This time we're going to have twice as much info because I have two groups that I should have sample data for. And then I state my hypotheses. When we are testing claims about a difference in proportions, you will typically see our null hypothesis written as P1 minus P2 equals 0. That is what the AP board is going to use. That is one of two ways to write it. Question is, what is that telling us about our population proportions? What are we assuming about our populations? They're the same, yeah. We're assuming that the population proportions, P1, P2, are the same. So another way you will see that written is P1 equals P2. When I teach this at the college level, that's the version that the textbook I teach out of uses. P1 equals P2. The one in black is the one the AP board is going to use. They're both saying the same thing, that there is no difference between those two proportions. Alternative, we know that the parameter should be the same. So this should also be a P1 minus a P2, or a P1 and a P2. I know if numbers show up, the numbers should be the same. The question is, what goes between the parameter and the number? And for the alternative, it should be, it can be not equal to, that's our default if we're not given anything, or less than or greater than. Not equal to tells me that those two population proportions are different. Less than tells me that population 1 proportion is smaller than P2. Greater than tells me P1 is greater than P2. Either of those forms, black or red, will get you full credit on the AP test. Pick out whichever one makes more sense in your head conceptually. I teach that at college because that is what makes more sense in my head. Your book is going to use that, but the AP board recognizes both as equivalent, and both will be marked correct on the FRQ. And that's it. That's plan, right? Everything from the problem. Plan. We identify what we're doing. This is a 2-proportion z-test. We are testing a claim about 2 proportions using the standard normal distribution. And we have to check that the conditions to perform that method have been met. There are 3 of them: random, independent, normal. Same thing we've been checking all of Unit 6, right? Random, independent, normal. Random, we look in the problem. Sampling or assignment needed to be randomized. Independent, how do I check for independence? 10% condition. Very good. I have to do it twice because I now have 2 sample sizes from 2 populations. So that means 2 10% checks. Good. What about normal? Large counts. Large counts involves n times p, n times q, which means 4 checks because I have to do n times p and n times q for sample 1, n times p and n times q for sample 2. Some textbooks will have you do n times p hat and n times q hat, where the p hat and q hat come from sample 1 and sample 2. Sometimes what you see statisticians do is to use something called a pooled proportion instead to perform these checks. And the pooled proportion, I do not like that alliteration. We're basically taking those two samples and operating on the assumption that the null is true, squishing them into one group. So the pooled proportion is the sum of the number of successes, the total number of successes for both groups, and then the sum of the sample sizes, the total sample for both groups. And if you use the pooled proportion, it's then N1 PC and N1 QC, and then N2 PC, N2 QC. You have to use the pooled proportion anyway when you calculate standard error. You might as well calculate it at the beginning and use it to do this check. If you forget and you do N1 P1, they will not deduct points on the AP exam. That is also an alternate method that is acceptable. The important thing is you have to do N times P, N times Q for both samples. That's where they're going to hit you. At this point, we're at the halfway point. Next step is the plug and chug. I got to calculate two things. Who can tell me what they are? I know, it was last week. We've had time to forget. Shauna. We need standard error as part of a larger calculation for something. Close. Test statistic. It's called a critical value for confidence intervals, C with C. For significance tests, it's called a test statistic. And then we use that test statistic to find what? I can tell who's done their week 3 homework recently and who hasn't. P-value, the thing we use to make our decision. The p-value is my evidence that either supports or does not support the claim. I need that p-value. Because I know when I go to do my conclusion, the little rhyme that runs in my head is if the p-value is low, reject HO. I need that p-value. To calculate the test statistic, the formula on your equation sheet for test day will say standardized test statistic equals statistic minus parameter over standard error. That's where the standard error comes in. Our test statistic is P1 minus P2 for the samples, because that's the proportion we're testing, P1 minus P2. So P hat 1 minus P hat 2. This should be population P1 minus P2. Why does it say 0? Take about 60 seconds. Discuss with your neighbors. Why is the parameter portion of this test statistic 0? All right, do I have a volunteer? Why does that equation say 0 where we should see the parameter? Null hypothesis. Very good. Null hypothesis, we're assuming that that difference is 0. Yeah. And our null hypothesis is always going to be there is no difference. They should subtract and give me 0. Good. The denominator kind of looks like our square root of PQ over N, but now I have 2 samples, so I have 2 1 over N's. So it's P hat C times Q hat C times 1 over N1 plus 1 over N2. Do I expect that you have that memorized? Heck no. On test day, where are you going to find that standard error formula? Backside of the equation sheet. Good. There should be a table with all of the standard errors, 1 prop, 2 prop, 1 mean, 2 means. It's all there. Yeah? You should be using the equation sheet during homework so that when you see it on test day, it is not this unfamiliar beast that you don't know how to read. Where can you find copies of the equation sheet? We know we have them in the classroom. They're in the yellow bin, but where else? When you're sitting at home, where can you find them? Google Classroom. There is a tab under classwork that says important paperwork. Somewhere in there is the equation sheet and tables that they will give you on test day. If you forget that, Google search AP Stats equation sheet. It is all over the web. Right? Like tons and tons of people take this test. That equation sheet is publicly available. Pull it up, use it while you're working on your homework. My recommendation when you're doing homework is if you don't know how to do something, the very first place you look is an equation sheet, then the notes in your textbook. Because ideally the goal is by test day, the only resource I need to solve a question is my equation sheet, because that's all I'm going to have on test day. So having that equation sheet out and using it as the first go-to is going to help you prep for AP testing. Good, good. Last step, conclude. We know there's 2 sentences, one for the null, one for the alternative. We love our sentence frames. A side note, because nobody wants to have to do that nasty equation by hand on their calculator, stats, tests, and we are doing a 2 prop Z test. And I believe it is option 6 under the test menu. I remember from this morning correctly. You choose calculate in that option, it'll spit out the alternative hypothesis and then your Z and P. If you select draw, it'll draw the normal curve that you're supposed to draw on your paper and then spit out the Z and P beneath the graph. Okay. Questions on the flow of problem solving for a significance test for 2 proportions? Process sounds vaguely familiar? Okay, so all we're doing today and beginning of tomorrow is examples. Yeah? Maybe. There we go. All right, so it says the Helsinki Heart Study recruited middle-aged men with high cholesterol levels, but no history of other serious medical problems to investigate whether a cholesterol-reducing drug could lower the risk of heart attacks. The volunteer subjects were assigned at random to one of 2 treatments. 2,051 men took the drug that I cannot pronounce to reduce their cholesterol levels, and a control group of 2,030 men took a placebo. During the next 5 years, 56 men in the medication group and 84 men in the placebo group had heart attacks. Do the results of this study give convincing evidence at alpha equals 0.01 significance level that the medication is effective in preventing heart attacks? Interpret your p-value from part A. So, first question, what are we being asked to do? And the answer is we know because it's the title of the notes today. We are being asked to do a 2 prop Z test. Where is the wording in the question that tells me that? Raise your hand if you know. Preferably someone in the back over here. It's been pretty quiet. How do we know? Wording in the question. How do we know? Oh, tears. Tears. It's been 3 days since the last time we did this together. You've forgotten everything. Oh. I know anytime they're asking me about convincing evidence, that's a significance test. I know anytime they give me a significance level, that's a significance test. How do I know that it's 2 proportions and not 1 proportion? Very good. I was given information on two groups. So there's 2,051 men who took the drug, and 56 of them had a heart attack. And then there were 2,030 men who took a placebo, and 84 of them had a heart attack. So they're giving me a number of successes in a sample size, which screams proportion, and they gave me two sets. One for a treatment, one for a placebo. So two proportions. Good. Good. I need to take all of that information that's in that word problem and lay it out in the state step. So I'm going to zoom in here on that box. Very first thing we do, define our proportion in words. P1, P2. So population proportion of and then the thing that separates them. Group 1 was given a medication, so men on meds. The second group was given a placebo, so men on placebo. Who and what are we counting in each group? What am I keeping track of out of these samples? How many had a heart attack? So proportion who had a, that is not how you write that, had a heart attack. Yeah. Don't judge me. Do you know what that symbol means? Yeah, so the AP readers would know what that symbol means. It's a time test, right? We're going for speed. I know I have to give a lot of data and I have to do it about 2 samples. So I'm going to sort by what I need to give. I need to give a sample size for both groups. I need to give a number of successes for both groups. I need a sample proportion for both groups. So NX P hat, NX P hat. Need to do it for group 1 and group 2. Right, name of the game is speed. So sample sizes. 1 is my medication group. We had 2,051. Pretty sure I read the problem right. I see some nodding. Group 2 was my placebo group. We had 2,030. I see nodding. Good. For number of successes, X1, we had 56 who had heart attacks out of the medication group and 84 out of the placebo group. Placebo. Good. I want proportions. P hat 1, P hat 2. I know how to calculate those. That's X over N. X over N. I'm not going to write the fraction with numbers because its numbers are right above. So 56 divided by 2051, 027. Yes. Look at me remembering stuff. And then the next one is 0.041, 42. 41. Everyone should have their calculator out because this is stats class. 0.4 what? 4.1. It was 4.1. Okay, good. Perfect. I need one more proportion. What am I missing? It's the new guy. Yeah, p hat pooled p hat c, which is x1 plus x2 over n1 plus n2. When you plug this in your calculator, parentheses around the numerator, parentheses around the denominator. Who's got a value for me? What do you got, Drew? 3.4. Very good. Notice the pooled value sits between the two individual values, which we expect because we're kind of doing something similar to averaging. So that makes sense. Good. Very good. There are two things missing. One more number from the problem that we haven't written down. Significance level. I need my alpha. Yeah, good. Where am I going to shove that? I'm going to put that up here. We were told alpha is 0.01. They even labeled it in the problem. They told us it was a level of significance. Happy face. What else is missing? This is a hypothesis test. What do I need? Hypotheses, yeah. I need a null. I need an alternative. I know it's P1 minus P2 equals 0. P1 minus P2 and a 0 with a symbol underneath that we haven't, or in between that we haven't decided on. And this is where people get stuck, and this is a perfectly natural place to get stuck. We have to stop and think about what the problem is asking us to test. And they were asking us, is there convincing evidence that the medication is effective at preventing heart attacks? If a medication is good at preventing heart attacks, do the number of heart attacks go up or down? Down. So I would expect P1 to be lower than the group that's not taking the medication if the medication is actually effective, which means P1 will be smaller than P2. If I subtract a smaller number and a bigger number, and the smaller number's in front, what is the sign on my answer? Negative, less than 0. Yeah, this is a less than question. I expect the proportion of heart attacks in the group on medication to be less than the proportion on the placebo if the medication is effective. Good, good. Happy face. Quarter of the way done. Second step, we start testing things. Josh, got to go through 3 checks. What's the first one? You wrote it down, first page of notes. Went through 3 of them. Same ones last week. Check with your neighbors if you forgot. Random, very good. Random. We checked the problem. Did they tell us random sampling? No, but they did tell us random assignment to treatment groups. So we know we meet that condition. Good. Very good. Anai. Second check. Independence. Very good. How do we check for independence? Yes, gold star. Independence. So 2 statements, one for sample 1, one for sample 2. Sample 1, we had 2,051 middle-aged men. Should be less than or equal to 10% of all middle-aged men. And then I'm going to copy and paste, but I'm going to change the number to sample 2 size. Technically, there's a little bit more to this statement. What are we assuming about the middle-aged men? If you go back to the very first sentence in the problem, it wasn't all middle-aged men on planet Earth. It was all middle-aged men who what? With high cholesterol, yeah. So technically, if you want to be nitpicky, that should be in there somewhere. But again, we're timed. Perfect. Last one. Yesenia. Random, independent. What's the third check? Normal. Very good. Bonus points if you can tell me how we check for normal. Does Cami know? No? Does anyone at the table next to them know? Does anyone in the room know? Large counts. Large counts. Large counts. Good. That's 4 things. I need to do N1 times P hat C and N1 times Q hat C. I need to do N2 times P hat C and N2 times Q hat C. Is it tedious? Yes. Do you need to do it? Yes. They will deduct points if you do not check on an FRQ. Also, on the MCQ, sometimes this pops up as a do you know what the large count check looks like? And if you don't, you'll miss that MCQ question. So I'm going to start batch filling in. I'm going to work vertically as I build my equations outward. So sample size 1 was 2051. Sample size 2 was 2030. I'm going to multiply those by some percentages. Our P hat C, our pooled proportion, was 0.034. The other proportion should be the complement. So what is 1 minus 0.034? And the answer is 966, because I've done this today twice. And while you are plugging and chugging away on your calculator, what do I want all 4 of those numbers to be? Very good. The check is all of these should be greater than or equal to 10. Yeah, no. I have too much trig on my calculator from my last 2 classes. Somebody's got to give me these. All right, Bailey, can you tell me what N1 times PC is? 69 point, and I'm just gonna 7. Thank you, perfect. 69.7. Very good. Jaylene, what did you get for N1 times Q? Is it 81 point something? So 0.3. Good? Happy face. And then the next one, Ivan, did you get N2 times PC?
Yeah.
What'd you get?
69.02.
Very good. Jacob, what'd you get for the next one? 1,961.0. Thumbs up if we got values around that. I see thumbs up. Perfect. All of those are much bigger than 10. We are happy. What comes next? The do. Yeah. Now that we've done all that prep work, now comes just the math. And if we did the state step correctly, when we go to the substitutions, we're pulling numbers from the top box into the bottom box. That's why I built that page that way. So, test statistic. We write the formula first. P hat 1 minus P hat 2 minus 0, because we're assuming that P1 minus P2 is 0, over square root P hat C, Q hat C, 1 over N1 plus 1 over N2. Again, the general structure of the equation is on the front side of your equation sheet. The standard error in the denominator is on the back side of your equation sheet. You don't have to have that memorized. Yeah. Next, I show the numbers substituted into the formula. So P hat 1 was 0.027? Question mark? Somebody who's looking at their paper?
Yep.
Yes, thank you. Minus 0.041. Minus 0. All over. Big square root. 0.034. 0.966. Come on, pen. Times 1 over 2051 plus 1 over 2030. And if you are a masochist or you took stats in the 90s, you would plug that formula into your calculator with lots of parentheses to make sure it did it correctly. You are not going to do that. What are you going to press on your calculator? 2 prop z test. Stat test 2 prop z test. I'm going to give you about 2 minutes in your small group to run that 2 prop z test command and get an answer for our test statistic value and our p value. Graphing calculators. Not with you or not at all?
Not with you.
Okay. Test date. You'll need it on Friday and Monday. One person at a table of 4 has a calculator? One?
One time I lost it. I forgot it.
Oh, forgot it, not lost it. Okay, that's...
I've been reading it.
Okay. We can fix forgetting. Losing is a whole other thing. One calculator at a table of 3?
I keep forgetting mine.
It should live in your backpack.
I know, but I took it out when I was doing homework and I never put it back. I got you tomorrow. I won't forget.
Friday and Monday are the big days because that's test day. You need it a Friday, Monday. Calculators. Ooh, 3 calculators. Good. I see numbers, which are good. Oh, the symbol for that should match whatever the symbol in our alternative was, which I think was a less than
Oh
statement.
yeah.
Yeah. Mhm. Yeah.
What would the values be?
So you're down here
Yeah.
should match your alternative statement, which was a less than statement.
Oh.
Yeah. Okay. I am seeing some people with answers on their calculator. Negative 2 point, was it 47? 4 something?
Yeah.
47, perfect. And then the p-value was 0.00, and I think it was 67.
I think yeah.
68. Okay. You would be correct if you wrote 007. When it rounds and it's so small, I prefer to give another place out. It makes me nervous to only see a bunch of zeros in one number. Perfect. Perfect. There is one more thing that needs to be in that box in order to get our E, our 4 out of 4. What else belongs in that box? Close. But right idea, a graph. We need a graph. Silly little graph. Very good. We draw our little ghost friend. Nice, pretty bell-shaped curve. It is a standard normal curve because we met the normal condition. We know zeros in the middle, 3 standard deviations out in either direction. Again, we should be practiced enough drawing that curve it comes normally, comes naturally. Yeah. We mark our test statistic. Negative 2.47s between -2 and -3. I shade in the direction of the inequality in my alternative. It was a less than, so I shade to the left. And that little itty bitty area there should be 0.0068. That's my p-value. That's what it represents. In other words, that proportion of all possible samples of the same size that we collected for this study will have a value that extreme or further to the left. Is that likely or unlikely? That's unlikely. That's less than 1%. So as a statistician, generally, I'm comfortable stating that what we saw in our study is unlikely to happen due to random chance in sampling. I do have evidence to support my claim. The check is we take that p-value, we compare it to our level of significance. Is the p-value less than our alpha or more than our alpha? It is less than our alpha. If the p-value is low, you reject HO. Because our p-val of 0.0067 is less than alpha equals 0.01, we reject HO. First of 2 sentence frames, right? I'm giving my evidence, and then I'm stating my decision. Because my p-value is lower than my level of significance, I am comfortable rejecting the null. If I reject the null, do I have evidence or do I not have evidence for the alternative? And I see some nodding, we do, yeah. Our test statistics, -2 point something. We're way out past 2 standard deviations on the lower side, meaning our p-hat1 was significantly less than p-hat2. The proportion of heart attacks in group 1 was significantly less than the heart attacks in group 2. So yes, we have evidence that the medication was effective. So we do have convincing evidence that the medication is effective. If I knew how to spell. At preventing heart attacks. Bless you. And I'm going to state the population that we performed this study on. Who are we trying to prevent heart attacks in? Middle-aged men with high cholesterol. Good. Which is happy face as a middle-aged man with high cholesterol. I appreciate that there are meds that do that. I don't want to die today. Question for the class. See who was observant when we started this process. Am I done with this problem? No. No, what I just wrote in that conclude box is my answer to part A. They asked us a part B. This is one of those few instances it is okay to make a frowny face in stats class. What did they ask us to do for part B? Interpret the p-value. I need to know what that p-value is telling me. So if I do repeated sampling from this same population, middle-aged men with high cholesterol, I randomly assign them to two groups, one med, one placebo. There is a 0.68% chance that that random sample will end up where I am or further out. So of all possible samples I could draw, less than 1% of them are where I am or more extreme. And no, I'm not writing it out because I've been writing all day and I'm tired. Ooh, we're typing. Now I have to think about what I said. I'll write it down. Otherwise, I'll forget what I said again. Oh, maybe I won't write it down. Is it going to let me move? There we go. Okay. So first thing I'm saying is if I were to do this process over again, exactly how I did it for this study, there is a, and then I'm going to state my p-value, 0.0068 chance that p hat 1 minus p hat 2 will be as extreme or more extreme than our sample statistic. I know how to spell. There is some wiggle worm with how you phrase this one. There isn't like a hard and fast sentence frame like there is for the conclusion. You have to get in there that we're performing the sampling method. In this case, sample of the same size, random assignment in the same way. And that when we do that, this is the likelihood that we get a sample statistic as extreme or more extreme than the one we saw in the study. Meaning virtually no chance, less than a 1% chance that that would happen. I see some nodding, which is a good thing. Okay, we have less than 10 minutes of class left, I think. Oh, my clock needs to get fixed badly. Yeah, that is so far off. 2 minutes. We will do two, just the do and conclude as our warm-up tomorrow. Bring your notes, bring your calculator. Tomorrow we're going to start reviewing for our Unit 6 test. I'm going to come around with your frappies from last week. There you Yari, Jaden. Chris. Ricardo. Josh. Ashley. Bailey. Samuel's not here. Jacob. Austin. You're welcome. Jennifer. Addie. Shauna. Sonia. Sophie. You're welcome. Cami. Amanda. Jillian. Drew. Ivan. Anna J. Anna. Anna. Sophia. Ivan, would you do me a favor since you're standing up? Would you press the stop button on that little recording square at the bottom corner?